concentricity. Concentricity. So first thing is that you need to understand the drawing. Okay, what is meant by datum A? Where's the datum A feature? Okay, so the drawing will be on about this workpiece. This is a workpiece. Okay, so datum A is this diameter here, which is diameter 68. Datum B, no, there's no datum B. So therefore, this datum you need to make sure that the axis is in line with the axis of the machine. Clear? Datum A. Then we have to measure the roundness of datum A. Then after that, we measure this diameter here. This diameter we need to measure cylindricity as well as concentricity with respect to A. Okay, so you need to have a drawing. Looks like you all don't have drawing, then how?
I'm drawing my tooth.
Ah. Okay, so this is called the roundness machine from Mr. Toyo, round test. Round test. So this is the base. Okay, all the drawing is there. Alright, the various part of the drawing. So this is the base, and this is the lottery table. Okay, lottery table is a special lottery table. Not only it rotates, but also it before you do the measurement, it can help you to do the alignment of the axis with respect to the axis of rotation. So this machine, the most important thing is the air bearing, which is constructed inside here. Okay, and very precision. Every year we need to calibrate to ensure that this axis is parallel to the axis of the whole machine, especially the z-axis, right, and perpendicular to the table here. This is the alignment table. Okay, so that you can align the job with respect to the reference axis. So whenever we measure roundness, okay, or any round component, we need to use this machine, especially roundness, cylindricity, concentricity, anything that is round. Okay, you want to measure all the geometrical tolerances. Over there, you can see roundness, cylindricity, flatness, straightness, concentricity, coaxiality, circular runout, total runout, perpendicularity. So this machine is meant for geometrical tolerances on a round part. All those geometrical tolerances you can measure on this machine, and the range is about 250. Okay, and the diameter can be up to 450. Okay, and the weight can be as heavy as about 40 kg, no problem. Okay, any question? So yeah, continue with the various part. So this is the vertical slide here. On the vertical slide, there's an arm. It's an arm. Okay, so this will give you the z-axis, and then the sensor is here. The sensor will pick up points on the workpiece. Any question? The sensor over here is also known as the detector, which is in the diagram. The detector head is here. Okay, so the detector head can apply pressure to the outer surface, okay, or the inner surface. If you want to measure anything in the inner surface, so the pressure should be this side, right? So you can rotate. Okay, you can loosen this part. Okay, now you can just rotate here okay, inside here, right in it's there's a 5 here, 3 and 1 to 5 that is the measuring force, okay, inside and then the outside over here there's a range of 1 to 5 or so. So normally we take 3. Okay, so there is a pressure on the workpiece, the force on the workpiece, which is in terms of Newton meter, 1 Newton meter to 5 Newton meter. You can select from here. Out means outer surface. In means inside surface. Okay, and then you can also measure top face and bottom face, which I want to show you, but unfortunately this is a bit too tight. You can also rotate this way. All right, for outer surface, right, you can rotate. Then you can rotate the sensor also. Okay, but please all job all vertical, so you don't have to play with this. Okay, you don't have to adjust this. Okay. You don't have to adjust this also. Only you adjust the force. Just check the force. Always reset for you. And this probe, right? Make sure at 0 degree. Right? There's a angular movement here, right? The reference point, white dot, okay, and the 0 in line. So if it's in line, you will find that this sensor is a bit inclined this way, so that when you touch the surface, there will be no shanking take place. Okay, when you touch to the actual force, you will be vertical, so there's no cosine error. Clear? Okay, so first thing, of course the control panel is here, the controller is inside here, the controller is here. Okay, so now we can now start to on the machine. So you have been working on the lab already, so you should be very familiar. You need to follow the instruction step by step. Okay, any step not clear, you need to ask. So the first step, alright, is to on the power, right? Okay, second step is to on the dryer here. Please change, there might be some mistake. Second step, once the power on, you on the dryer here. Okay, then you on the air, turn on the air here, the main, and then after the service unit, there's another lever here, another valve here, you need to on. Then it goes to another valve here, okay, which is the machine service unit here. So there's two service unit. One service unit after the main, okay, another service from to the machine, before the machine, going to the machine. Then you can on the controller, right? On the controller here, make sure the system no need to off, okay, but the power you must on. This one, system always on, don't off it. Okay, then you can just start the computer. System. There's a button for the computer. Oh, this is the tray. Okay, while waiting, we can now discuss alright, about what you're supposed to do. So first thing is that you need to place your workpiece on the on the table, stage here, or the lottery table. You can see once you on the lottery table is free to rotate. Okay, without air you just cannot rotate. Okay, because of air bearing. You can check the other side. You just cannot rotate. Do not force. You cannot rotate. Don't force. You all measuring machine, you shouldn't be forcing. Okay, next is the software. You can activate the software. The version is here, round pack. Okay, roundness package version number 7.3. Then we can zero set the machine off, or re-zero the machine. Okay, or home the machine. Okay, you can see this home is there, so you just say okay or yes. So this is to initialize the reading of the machine. The machine has got x-axis. X-axis come from the arm. Okay, then z-axis from the column of the scale. So there's a scale inside here. There's a scale here behind that you can see, and there's a few scale here. One is the axis rotating angle, right, of the lottery table. Okay, over here you can see rotating table. Now is 0 degree will be here. When 0 degree is always at this position, right? You all know a circle, right? 0 degree is here. Okay, can see about 360 degree or 0 here. Can see? Okay. The radius is from here, center axis, to here. Okay, and then the z, and the x is the same thing. Radius and the x is the same value. Okay, why we check roundness? Anyone? What is roundness? What is round? What do you mean by roundness?
The tolerance formed between two circles.
Nobody can understand, right? What do you mean by that? a layman
There,
term.
see.
Any circumferential line must be contained within the tolerance zone formed between two colorblind.
Yeah, what is that? What is the meaning? Nobody can understand.
So that means in between two circles, then is
Coplanar.
the
Is it planar or planar?
in between the two
I think it's
circles.
planar. I think it's planar. Coplanar.
We covered that right in the class. Do you cover roundness already?
A bit lah.
The test tomorrow only topic 3. Means topic 4 you haven't covered. Topic 4 is roundness.
Topic 4 start a bit lah.
Start.
Yeah, start already.
So tested tomorrow.
No, it's just 3.
No what?
You want to test? I
Don't
can
want,
test you.
don't want. Because you say touch already, later I scared
Yeah.
to test.
So, what is roundness? We already discussed that. What is roundness?
It's exactly this.
No, it's he wants the layman terms.
Yeah,
Oh,
layman term. This is a technical term, right? Which engineer then speak about this.
It's,
So if you talk to your friends,
So
okay,
it's
in the
circle.
yeah,
it's about
The tolerance between the two circles.
but people don't understand what tolerance between two circles. We are
maximum-
talking about roundness, and they talk about two
minimum
circles.
how
No,
like spherical the object is. It's how smooth.
Please don't say how round.
That's why I'm trying to use other terms.
How round it is.
Yeah.
That's all you can say.
No, it's gonna be such.
so how you draw with a compass? A circle.
compass.
Yeah.
How you draw?
Yes.
You put in the center. Then,
Oh,
you-
center.
Then you
Then what happened?
then what happen?
Yeah. What happened?
a circle will be drawn.
Circle will be drawn. How? Is it round?
Oh,
It's,
How you know that it's round?
it's not round, it's circle.
it is the same.
It's round.
It's round. It's round because there's no like
What?
it's perfectly circle.
Why?
Oh.
Why perfectly circle?
Because. Why is
All radius are equal. Okay.
Oh.
Shit, yeah.
From a common center. That's what a layman can tell you, right? Okay. All the distance, all the distance, all the point on the circumference, okay, is
I didn't ask this one.
equal. All right. To the if you draw any point to the center of the circle, okay, all the point you draw this way, all the radius is equal, right? So that when you open up the compass, you see you open up the radius, right? Okay, and then you don't change. Okay, you draw a circle. So with all the radius equal. Clear? Yeah. But to define that, we use a term like this. Okay, that a round job means we need to plot all the point, okay, and then we need to make sure that analyze the all the radius. Is it equal or not equal? Okay, and then if it's not equal, meaning when you draw a circle, okay, you need to draw two circles, right? One touching a radius further away from the center, another circle touch the smallest radius, right? Okay, so the distance apart will define what you call roundness. Okay, the difference in the radius. Okay, so first thing, you might want to stand up, stand up and have a look, how I set up, otherwise you don't know. Okay, so handle thing with care, okay, and then you need to clean the table, okay, and your workpiece. Okay. So this job is very heavy. Do not drop the workpiece, okay. Then put it exactly in the concentric circle. You have the concentric circle, can see? Okay, before that, we need to also re-zero this table. Okay, so the table, how to re-zero? Under measurement, table reset. Can see?
Yep.
So there are two commands here. Home, at the end of the day, at the end of the day, after working, after finishing, you need to home here. Home position, then reset the table is here. You need to do these two things. So you can see this table can be tilted along the x-axis, along the y-axis. At the same time, you can move along the x and the y. Okay, for your alignment of the center point, okay, or axis of your workpiece. Okay, first thing, put it in the center. of the concentric circle, any concentric circle. The nearest will be this one, right? The smallest. Then you can see it's offset, right? Not equal. So it just along the axis, 0 to 180 degree. Make sure is set equal distance. Then 90 degree, 90 and 270 degree C is equal. No? And then you repeat. Okay, fine. Any question? Okay, next step is to bring down this. You on the X and the Z button here on. Then you can move along the Z and the X. And then you the tip here, if it's dirty, you clean it first. Hold it here, support. Okay, and then you just clean it. Is this clear? And then you can bring it closer to the diameter A. Diameter A is this diameter A. This diameter A. About 1 mm away. And in the center plane of this is height, right? In the center of this height. Okay, then there's a gap, right? You can see there's a gap. So you rotate and observe the gap. Okay, and then you can bring it closer to reduce the gap. Okay, and then observe the gap. So is the gap equal or not when you rotate? So there's this dial here for moving the X and Y. Please don't go and rotate this. This is a motor. Don't put your hand here. Put your hand here. This is a handle. Am I clear? Yeah. Then observe the gap. Equal or not? So yeah, it's very equal. If it's not equal, then you use this mallet to tap. Tap this side, not tap this way. Tap this way, you will hit the probe and then your sensor. So always tap away. So at the smallest gap, you just tap away. Okay, so at 0 degree, you set to 0. Here, there's a meter here, can see? Position meter. Now it doesn't sense. So sense is by pressing auto set here. There's a button here, auto set. Sense. Okay, and then the meter will be set to 0 right here. Can see 0. And then you observe here also 0. You can see here also. The digital reading is here. The analog reading is here. And you can check the lottery table rotate about 6 revolution per minute, and the magnification can be increased to 100K. So for setting, normally you use the lowest. Okay, lowest magnification. Okay, then you can now rotate and observe here. Please observe the meter. Okay, all reading must be at the positive side. So the negative side is this side. So you should at the negative side you set to 0. Okay, okay, at 90 degree. No, at 0 degree, it is 0, right? Can you see? At 0 degree is 0. Okay, and then you can rotate until you got maximum reading. Stop there. Can you see maximum reading? Stop there. Then you can tap your workpiece now. Tap your workpiece this way. Okay, it's just tap half the distance. Because it's a radius, right? Always half. Then you can now set to 0 here. Again, you can go back to 0 degree. Go back to 0 degree. Okay, and 0 set. And then continue to check whether it is okay. So you can see now it's almost there. Very good. Okay, this rough alignment, this is called a rough alignment. Then very fine alignment at higher magnification, you need the software to help you to do the alignment. So in order to the alignment also based on the tilting. Okay, we only check the circle. So but only one section. But the axis can be tilted this way or that way, right? Okay, your workpiece is so tall, right? So you might be tilting this way or that way. Are you concentrating?
Yeah.
Be mindful, please. Just listen. The rest all you should refer to your notes, okay lah. But you should shut everything away. Alright. Okay. Just concentrate. Alright. What I'm saying. Okay. Next is to do alignment. Alignment, you need to use the alignment icon here. So everything will be on the machine now. You can see a blue icon here. Can you see a blue icon here?
Yes.
You can see this is the CAD drawing. The CAD drawing. Computer aided drawing. You don't know. Okay, can see the sensor? So it's exactly indicating the position of the sensor. Okay, for this machine because we already calibrated, right? It is exactly there. And this drawing I have drawn it already over here. I provide you this CAD drawing, 2D drawing. Okay, so there's icon here. You can now the layout is not so good. You can just under here, under the view, you can reset the under edit. Sorry, no, under here, there's an icon on reset window layout. You can see if your window is missing, you just come here and then you reset the layout of the. Then you can see all your window. So this window here is the measure condition window. This one is a part programming window. This is the sensor as well as the CAD drawing. Okay, for you to see where is the sensor. This one is the machine control. Okay, and over here all the command here. Okay, and over here is a setting command. So our setting command that we are interested is here, centering and leveling. So you need first step. Hey, don't dirty my chair off.
Actually, very clean one.
Yeah, I know, but you're dirtying my. Okay, under execution, first step is simple measurement. Then say okay. What is the next step? Please tell me. What is the next step? Open up.
Wait.
Yes, sir.
Yeah, what is the next step? Read it up.
Show him, no, he also
Okay,
know.
fine.
Now we are in step number.
Click OK already, right?
Step number 3.
Number 3. Click on
Form
Form
trace
Trace Pack.
Form
You
trace.
click already, what?
No, that's a preparation. I'm talking about now alignment.
No, that is the measuring procedure, yeah.
Measuring procedure is first is the preparation done already.
Click measurement. Click
I
already.
think he's right here now.
Where am I?
Yeah. Very far away. Okay. Click parameter.
Okay, no. We the first procedure. Procedure number 1. There's so many procedure. Procedure number 1 is on the preparation. Already done.
There's
Finish
no,
already.
no, the
Then procedure number 2 point something, right?
No.
That is procedure number 2.
So we only got
no,
1 to
teacher
20
only, we
something.
only got 1, 2, 3, 4.
We got until 1 to 20 something.
That one to 20
Yeah.
something is preparation
No,
under procedure number 1.
But that's all we have.
Yeah, that's all we have.
Huh?
We only got measuring procedure, you see.
Oh.
It's not, I cannot
This is definitely Chinese. This looks Chinese, so this is Chinese.
You are in a wrong exercise.
This, this is exercise 4.
This is surface. We are talking about roundness.
No, teacher, you said exercise 4, then we go
Exercise-
exercise 4.
Is it?
Yeah, that's USD.
So it
It's
should be what?
exercise 4.
Should be what? Roundness measurement should be what? 5. Exercise 5. Understand or not?
Oh, no lah, cause you say 4 then we just open blindly. Oh, 2 point something is it? Place the workpiece, place already. Activate Z and X button.
Just now
Activate. Set stylus to measure.
Step 3, step 3.
we have finished all that.
This is from step 3. He just
Ah.
Oh.
step 3.
Step number 3.
Program. Execute.
Yeah, then over here, simple. Under execute, right?
Simple measure.
Simple done already. So what is next step?
Right click the centering and
Ah,
leveling
yeah.
icon.
Here, right click here. Right click means what? What is right click?
Huh? Click the right button.
Yeah, click the right button.
Not
So
use
on
the
your
right hand
mouse, on your mouse, there are left hand click and right hand, and then there's a center button here. So we are using the right hand click here. If I say right hand click, that means it's here. If I say click, it's here.
Mm.
Okay, so right hand here,
Oh, Jesus.
click.
This is real.
Okay, what is next?
Okay. Select condition tab.
Here, there's a tab condition.
Set measure element to outer.
Yeah. Here, okay, there are many direction of element. So we always measure outer vertical. Vertical.
Okay, okay.
Please.
Vertical, guys. Vertical. Execution style change to repeat change already.
Yeah.
Request magnification 1 done. Max loop 5 done. Select auto follow.
Yeah, auto follow. Okay.
Change to normal. Yeah.
Auto follow.
Okay, quite done.
Auto follow normal, right?
Yeah. So go measure condition.
Measure condition.
Move stylus to measure position of the first element.
Okay, so how to move? Alright. Are you listening?
Yes, I am.
Okay, so the sensor is here now. We need to measure 2 slices, 2 elements. One element below here, another at 1 circle below, about 1 mm above here. Okay, and then the other element is from the top, okay, of this to slightly below. Okay, slightly below this edge here, about 1 mm. So first position is now currently Z is 63. Okay, so 63 is here. We want to bring it down. Okay, about 1 mm above this edge.
Okay.
Okay, so down, how to bring here? Hello, there's a move here.
I think must move this one. Right?
Yeah, here. You can move here or you can manually. My suggestion is you move manually here. Okay, move down. See where you are. There is the press.
Which already?
Okay, so about 1 mm. Any question? Okay, and the reading now is 57, right? Change here. 58 is wrong. Click here. Okay, cancel. Right click. And then specify position reflect counter. Okay, so reflect counter means reflect this inside here.
Click on click.
Okay, can see. So now it's 57.56. Then you repeat. Okay, repeat this. Okay, cancel. Okay, right click. But
You haven't measure, right?
I haven't moved.
Yeah.
Okay, so you need to move first to the next position. About 1 mm below the edge. The stylus are 1 mm below the edge. Okay, then you can see 66.65, right? Then specify position, reflect counter. Any question? These two position?
Press OK.
Then press OK. Then what else?
Press the centering and leveling to
Yeah.
start process.
Press. Okay, press means this button here.
Yeah.
Same icon, press is to start.
Move the stylus to the first element.
Yeah, move. First element,
Press.
press start. So now you will do the alignment for us automatically. Okay, so this alignment will be includes not only centering, minute centering up to 1000 magnification. That's just our 100, right? Okay. So you also tip for us. Very fast, the process is very fast. You can't see. Okay, centering and leveling. Any question? The step.
No.
So you should follow the step closely. So we set to 1000 the magnification. So can anybody tell me why should we align the job before we start measuring the roundness?
I think we go to the
What is the reason? So second circle, alright, can see how they give a alignment error, okay? Then after that it disappeared, it actually move for us already. Okay, the action is very fast. And they can see now the magnification changed to 1000. Any question? So we expect that when I put it in the middle plane, middle here. Okay. Then auto set here, auto set is here. Okay. Then when you rotate the lottery table here, rotate the lottery table, the error will be very minute only. You see here, less than about 5 micron, right? 5 or 6 micron. But if you think that this is no good, then you need to repeat the alignment again. Clear? If this is you think that at 1000 it is no good, right? Okay, you can repeat this process again to higher magnification. But for our workpiece, 1000 magnification and an error of plus minus a few micron is good enough. Okay, any question? Then we can stop the lottery table using this button, and then we can move the stylus away using this movement, right movement. Okay, but the best is move there lah. Okay, for safety purpose. Okay, so next, what is the next?
Oh, next
Yeah.
measure the second part. I'll measure it. Right hand mouse click the roundness measuring.
So this is to measure the roundness. Okay, right hand click here, roundness. Then you use the
calculation method.
calculation method is here. Make sure you are measuring roundness.
LS.
LSC is a least square center.
Yeah.
Okay,
Outer.
outer roundness we are measuring one element. Okay. And then the filtering is 50%, and the cutoff is over here. This I don't want to explain to you further. Alright, the cutoff is, listen here, the cutoff. How to calculate the cutoff is the circumference of this diameter. How to calculate circumference? Anyone?
What's the circumference of circle?
Pi
R
r
square.
no pi r square is the area. Pi d pi no
2 pi r.
2 pi r
Pi r.
2 pi, alright, okay. Or pi d lah.
pi d
Pi d, okay, so the diameter of this is 68. Pi d is 3.142, right? Times 68. Clear? Then divide by 0.8.
How much? My calculator
Yeah.
calculating.
Yeah. 3.142 or use pi divide times 68
times 68
divide by 0.8.
3.142
You're not calculating.
So that is the cutoff. The formula for cutoff, circumference divide by 0.8. 0.8 is the sampling length.
267.06.
Correct, 267, right? Can see I select 150.
Yeah.
I can't select, there are two choices here, right?
500
I can't select more, I must select less. Okay, but if you want to input here also can, option you key in, but no need, we just select less. Okay,
That's okay.
cut off any question?
No.
This one, filter is to filter off the vibration, your system inaccuracy, vibration especially. Okay, so unnecessary point is picked up by the system, so you can filter off using Gaussian. What is Gaussian? Gaussian? Gaussian?
Gaussian? Maybe Gaussian?
What do you mean by Gaussian?
Cover?
50%.
Gaussian.
Uh,
Is it?
Normal distribution curve, right? Gaussian curve.
Oh, mine never put normal distribution.
It's a Gaussian.
If you say normal
and,
distribution, I
yeah,
understand.
okay. So what do you mean by 50% normal distribution? What do you mean?
So mean.
Huh? From the mean? What? What happened?
Teacher, the class got other people, so you can ask them.
Yeah, I'm asking everybody.
Because he looked at me, then I thought he asked me. I knew it's the mean.
Yeah. I also know it's the center point is the mean.
Yeah, center point is the mean. Then where is the 50%?
50% is your I don't know lower median.
Yeah, plus or minus, right? 25% from the mean. That is 50%. Okay. Then we only use about 50%. Within the 50%, alright, is okay. But there are outliers. Above that, you'll be discarded away. Will not be included. Okay.
Yes.
Then what? What else? Result, right?
Oh.
You want to see from the top view, the peak to valley height. Then say okay. Then you can start now. Okay. Start is to click here. So now it's starting. Then you can auto set first. Make sure auto set. Okay, you can see the auto set. Okay, whatever action is seen from here can be seen from here. Okay, then we can measure. Alright, if the sensor touches, you can start. Okay, so now we are measuring roundness. Okay? Are we following the step?
Yes.
Okay, any step missing? Where did I go wrong?
You need to press result.
Something is wrong. What? Anyone can tell me? Okay, I put new one. I will measure again. You didn't okay, so what? You need to change the
change
magnification
the magnification to 5,000.
5,000. You never
Speed
tell
is
me.
6.
Speed
I
is
thought
6.
you changed already.
Speed is 6, huh?
Yeah.
Okay, then
Yes.
start again.
Click on the roundness icon.
Okay, click on the roundness icon.
Move the
Okay,
stylus to the midplane.
Move the side.
already in the mid plane, right? Okay,
Then
okay.
click auto set.
Auto set is here.
Start.
Then
Track
click
is
start.
Then click start. Here, start is here. So the magnification very important in roundness. You need to magnify the radius.
Then
Error of the
after that you need to
radius.
stop the. After that you need to stop the table.
Yeah. So you can see there's a peak here. Can you see? So I hope we can measure the whole.
It's not super round.
Yeah, correct. So it stopped. Can you see? Out of the range, 5,000 is too large. Cannot be detected.
Then how?
So how? Reduce the magnification. Understand? Reduce here.
Then why here never put?
Of course, that's why the training is important, right?
Oh.
That's the reason why you have to come for training.
Yeah. This is training.
Okay, then start again. So you cannot measure at 5,000, you reduce, or you clean your
Then you
workpiece.
reduce to
The next step. The reason is because there might be a dirt there. Okay, you need to clean actually. The stylus also you need to clean, which you need to check lah. There's a peak here, right? At 0 degree, there's a peak here, so you can
Okay.
clean.
Yeah, then click calculation.
Okay, so stop first.
Move to a safe place.
Stop first. Lottery table,
Yeah,
stop
stop,
first. Move the stylus to a safe position. So you can see a circle is being measured, the blue color one. Okay. Then you can press the calculation. You can see
Done, yes.
either click calculation or result screen here.
Click calculation.
But I'm just telling you,
yeah.
if there's no this button here, please click here, result screen. Okay? So the
Click on the pinky
here.
icon.
So 4.5. Is it okay, roundness? Within a specification? Can you please check the drawing? What is the tolerance required? Roundness.
For which one?
0.2. Symbol. 0.02.
Yeah, 0.02. And now is what is the reading? So here.
One.
About 5 micron, right? So 5 micron is what? 0.005. Any deviation?
Yes.
Is it in or out of the specification?
0.005.
In or out?
It's out of deviation.
Out of the deviation. Then you will fear.
0.02, 0.02. It's like 1.5.
Not 1.5 lah, 0.00.
As in like in terms of micro.
So is it in or out? I'm asking a question.
Out.
Out.
Out, ah? Then you will fear my module.
No, it's in because it's 0.005. That one is 0.02.
This is micron,
Yeah,
understand?
the one, this one is
How many? What is the tolerance? How many micron? Tolerance, how many micron?
0.02.
0.02.
How many micron? In terms of micron?
This is mm, right?
20.
Drawing is always in millimeter. Huh?
Micron.
20 micron.
It's
So
4.537 micron means it's in.
then any deviation? Any deviation? Where's your? Anybody print up your
Only worksheet.
worksheet? So my question is here, okay, over here. Record down the result on the
deviation.
table.
No deviation.
Yeah, okay. So your specification is 20 micron. Your actual is 4.5 micron. Okay, so deviation is value out of the tolerance, right? We discussed it.
0.
So it should be 0, huh?
So we marks in.
Yeah,
Accepted.
within the specification, accepted, right? Huh? The result is accepted. Clear? Any question? Okay, next icon. What's supposed to be measured? What's the next step? So you need to go back to the measure screen.
Press PT.
Press PT. Very good. Okay, what is next?
Open the new file.
New. Open the new file here.
Right click the concentricity icon.
No need to save. Okay, record down the result already. Or if you want, you can print out the result. Okay,
Right
save.
click.
Okay, so
Concentricity.
okay, which one? Concentricity icon. Which one?
The
It was the first.
Which one? There are two. One with a black dot.
The one without the black dot.
Without the black dot. Concentricity.
Yes.
Okay, then right click. Right click.
My watch.
Okay. So you need to concentricity. Please listen here. You need to measure this diameter at the top. Okay, another diameter will be the datum. So you need to measure this at the middle. Okay, plus another. So you measure this with respect to A. Clear now? Whether there are two elements. So the datum A is here, and concentricity to be measured is here. So with these two circles, you can analyze the center point of this, whether is it in the center point or distance. Okay, where is concentricity?
The center point.
No, ask him. And then ask him.
Concentricity is the center point must be within the tolerance zone formed by the circle, the diameter, with the datum.
Where's the datum?
The datum is the red color one.
The datum is here. Is it?
That's my guess.
Your guess is wrong.
Okay.
Data in the circle.
Circle, just now the measure.
Center.
Where? How about you? Where? Okay, where's the datum? In this job, where's the datum? Where's the datum? Where? Top surface, here. Is it? Top surface here. Is it? Datum is here. How are you? Where's the datum?
The second ring.
Second ring. So this
Yeah, blue
which
dot.
ring?
No,
One ring here.
where your ring is, where your blue dot is.
Blue dot is here. So this is you can measure any circle in this diameter. Understand? This will be the datum.
Yeah.
Then where is the what are we measuring? Which circle? We are going to check which circle with respect to this datum.
The top circle.
The top circle here. You measure another circle here. You first element. This is called the evaluation element. There are two elements here. Can you see? We call evaluation element. Evaluation element is here. Clear? And then the datum element is here. Then you need to set. Okay. The same thing. You need to set whether outer, inner. What is a cut off? Okay. Over here. What is a measuring evaluation method? This square center method.
Check already, correct.
Here, click here, datum, also check.
Correct, check.
Yeah. The result is here. We wrote down from the top. Okay, the center, compare the two center point. Okay. Any question? Then say okay. Then you can start. Alright, concentrate, start.
Must change the magnification to 1000.
Change to 1000.
Then
Anything else?
Click on the concentricity.
Yeah, I'll click already. Then
Auto set. And
where?
Start.
Measure where? First.
Measure. Let me see. Measure on top one. Is the circle? Yeah.
Okay, so when you measure, you must measure the top first. Evaluation, right? Okay, according to the program is evaluation. So you can go up, right? Bring the stylus up. Okay, bring the stylus in. Okay, check that is in the middle right? So too high right? Here, middle is around here. Okay, the blue dot here. Can see? Then auto set. Okay, then you can stop. Any question? By the time you come back, it's about 3 weeks time.
To come back to do this.
Yeah, can remember week 12, week 11.
Watch the video of steps.
Yeah.
The steps can follow lah.
Yeah.
But teacher, you left 1 hour to do 2 more.
Yeah. Never mind. We will wait. We will. Yeah, it's okay.
Still got another
Because
class after
we
this.
got lecture after this.
Never mind. I cancel the lecture.
Huh?
Okay, this one. Play around.
Okay. Then after that, stop. What else?
Stop. Then press
Then
stop.
bring it.
Move the stylus to the datum element.
Yeah.
Then
Okay.
press
Datum
auto set.
element is here.
Then press auto set.
Then press start. Here. One hour. I think we can finish. 1 hour. I don't know. You pray hard. You pray hard. 12 o'clock is your next lesson. Okay, finish. Then you can stop. You can stop the lottery table. Bring the stylus to the safe position. Okay. Then over here you set to datum. One of the element, right? Datum element is this one. You set this one to a datum. There are 2 elements, right? Set this one to datum. Okay. Then you can see. There is red color here, datum. Then you can press the result screen here. Okay. Any question? Then the record down. So 24 micron in or out?
Yeah. 20 out.
Out by 4.
4
Deviation is 4.3. The deviation is 4.3, 4.4. Okay. Then you can go to PT. You can now bring the stylus to the top here to measure cylindricity. Any question? Cylindricity, you need to use a CNC mode. Okay, so you need to come here. Okay, uncheck simple measurement, change to CNC mode. Okay, or programming mode. Called programming mode. Uncheck this. Then the screen will change to gray. Can see gray color. Just now it was green, right? Now change to gray. Then you can bring this stylus up to the bottom here. Okay. So therefore you need to move manually here. Okay, we prepare the stylus here. Okay, and we are going to move, measure two circles. One circle slightly near to the edge, okay, bottom edge, and another one at the top 6 mm away. So with these two circles, you can analyze the cylindricity. Clear? Any question? So cylindricity is this icon here. You just click. Don't need to. Yeah. So cylindricity is here. Any question? Then you can start the program. Okay. Say okay. But you need to do setting. But I don't know why. Okay. I need to do some setting. A port this way. I think right click to set. Okay, 2 element, 6 mm, just double check. Okay, any question? You need to check this. All given in the instruction. Outer 2 element, Gaussian, cut off, okay, and the pitch is 6 mm. So you cannot put negative, negative then you got problem. Okay, then you can start program here. Okay, because the command is here, you can see. Okay, yeah, then you will automatically start for us. Start, press start here. Okay, start program and start. So you measure this circle, then you move up, alright, 6 mm. Okay, so you will move up by 6 mm. You can see the blue dot. Yeah. Then you will measure, analyze and measure the second circle, and you will analyze the cylindricity for us. Cylindricity. Okay, so you say okay, program M, okay, you move to a say distance, okay, then press the result screen here. So you give us the cylindricity. You can see cylindricity is defined by two concentric cylinder, okay, one touching the peak, the other touching the valley of the two circle that we are measuring. So 3.1, is it good or bad? Do we need a specification? Looks like only one student working on it. One student doing the yeah, in or up?
It's 20.
Yeah, 20.
So it's in.
In 3 micron. Okay, any question about this exercise? I finished my demonstration. So after finishing, you can home under measurement. You can home here under home position. Say okay. So you will return to his home position.